Now we will solve some more examples on Euler Lagranges equation satisfied by 4 times differentiable functions. First problem is find the function on which the functional Iyx equal to integral 0 to 1 y double dash square minus 2xy dx can be extremized such that y at 0 equal to y dash at 0, y at 1 equal to 1 by 120 and y dash at 1 is not prescribed. Here the value at one point is not prescribed. Here F is solution. F is y double dash square minus 2xy, and hence the Euler Lagranges equation for 4 times the function dou f by dou y, dou f by dou y minus d by dx of dou f by dou y dash plus d square by dx square of dou f by dou y double dash equal to 0 becomes, this equation becomes minus 2x, dou f by dou y is minus 2x, plus d square by dx square of 2y double dash equal to 0. That is nothing but d raised to 4 by dx raised to 4 of y minus x equal to 0. We shall integrate this equation can be written in this way: d raised to 4y by dx raised to 4 equal to x. Integrating this by successively, we get y triple dash equal to x square by 2 plus a. Again integrating, we get y double dash equal to x cube by 6 plus ax plus b, constant of integration. Again integrating, we will get y dash equal to x raised to 4 by 24 plus ax square by 2 plus bx plus c. Again integrating, we will get y equal to x raised to 5 by 120 plus x cube by ax cube by 6 plus bx square by 2 plus cx plus d, where a, b, c, d are constant of integration which we have to determine by using given condition. The condition y at 0 equal to 0, this implies d equal to 0. Y dash at 0 equal to 0, this implies c equal to 0. Y at 1 equal to 1 by 120, this implies one by 120 plus a by 6 plus b by 2 plus c plus d equal to 1 by 120. But c is a 0 and d is 0. This implies that a plus 3b equal to 0. Cancelling some terms, and simply we will get a plus 3b equal to 0. Here we got only one equation. This is the only equation. And we have to determine values of two constants or two unknowns. A and B. Here y dash 1 is not prescribed. That means y dash at x equal to 1 is not given. Then in this case we use the condition dou f by dou y double dash at x equal to 1 equal to 0. This implies y double dash at 1 equal to 0. And from this we will get equation 6a plus 6b equal to minus 1. Thus we have equation a plus 3b equal to 0 and 6a plus 6b equal to minus 1. Solving these two equations, we will get a equal to minus 1 by 4, b equal to 1 by 12. And therefore, the equation's required function becomes y equal to x raised to 5 by 120 plus 1 by 24 x square minus x cube. This is the required function which extremizes the functional. Next problem, example second. Find the function on which the functional I y x equal to integral 0 to 1 y double dash square minus 2xy dx can be extremized such that the condition y at 0 equal to 0, y at 1 equal to 1 by 120, and y dash is not prescribed at both the ends. What is the difference between previous problem and this problem? In previous problem, y dash at one end is not prescribed, and in this problem, y dash is not prescribed at both the ends. Let us see what can be done in this case. Solution. Here, f equal to y double dash square minus 2xy, and therefore the Euler Lagranges equation dou f by dou y minus d by dx of dou f by dou y dash plus d square by dx square of dou f by dou y double dash equal to 0 becomes d raised to 4y by dx raised to 4 equal to x. Integrating this equation 4 times, we get y equal to x. The equation becomes, integrating 4 times, the equation becomes y equal to x raised to 5 by 120 minus plus a x cube by 6 plus b x square by 2 plus cx plus d. This is the solution, where a, b, c and d are constants of integration which we have to determine. These constants we have to determine. Y at 0 equal to 0. This implies d equal to 0. Y at 1 equal to 1 by 120. This implies a plus 3b plus 6c equal to 0. Now, here we got only one equation in A, B and C. To determine these 3 constants, we need 2 more relations. It is given that y dash is not prescribed at both the ends. In this case, we use the conditions dou f by dou y double dash at x equal to 0 equal to 0 equal to dou f by dou y double dash at x equal to 1. The first condition, dou f by dou y double dash at x equal to 0, this implies y double dash at 0 equal to 0, and this gives the condition b equal to 0. The second condition, dou f by dou y double dash at x equal to 1 equal to 0, this implies y double dash at 1 equal to 0, this implies a equal to 1 by 6. If we substitute these values in above equation, we will get c equal to 1 by 36. Hence, a required curve is y equal to x raised to 5 by 120 plus 1 by 36 times x minus x cube. Thank you.